Hello and welcome everyone. This is a continuation of the project 0x02 functions and nested loops. So in the previous videos we've solved from task 0 to task 8. So today we are going to commence from task 9. So before I proceed, let me open my main.h file so that you can have a preview of what I have inside. So I already have this prototype inside this main.h file, which is this void times table, which is this void times table, and also the remaining prototypes in which we'll be using in this project. So I don't need to be opening the main.h every time. Alright, so this says we should write a function that prints the 9 times table starting with 0. So it says format, see example. Alright, so let's look at the example here. So as you can see here, this is where the function is being called. So there is nothing passed to the function as parameter because the function takes in what? A void, so it doesn't take anything as parameter. So when the function is called, as you can see, it's printed this 9 times table. So when you count this, we have how many rows? 9 rows, and we have 9 columns, right? Isn't it? Just count it: 1 2 3 4 5 6 7 8 9. Sorry, we have 10. We are counting from 0. It says what? Function that prints 9 times table starting with 0. So 0 to 9, if you count, is 10. Sorry, yeah, it's supposed to be 10 rows. And how many columns? 10 columns. So here in this case, I'm going to need 2 loops, right? The first loop is going to iterate over the rows, and the second loop is going to, the first loop is going to iterate over the row, and the second loop is going to iterate over what? The column, right? Okay, so now let's create the file. First, let's open the file, copy. So vi 9 times, I forgot I've already copied it, .c, right? Times table.c. Alright, so here I need to include my main.h. So main.h. So the prototype, which is this, then paste this here. Alright, so what's the first thing we need to do? Like I said, I need to create 2 loops. One is going to keep track of the rows, and the other is going to keep track of the column. So when you look at this, how many rows do we have? We have 10 rows, we have 10 columns, right? So it means that we need to set a limit for both our row, for both the loop of the row and the loop of the column to what? To 10, right? So let me first declare the variables that I'm going to use for this. So int I and j, right? So what's the next thing I need to do? Here I will now start the looping for the row, which is what I need to start from where? From 0, because it has stated it clearly from the question that starting from what? From 0. So starting with 0. So what should be the condition? How many rows? We have 10 rows, isn't it? So it has to be what? I less than 10, because the question says that prints the 9 times table. So if you count from 0 to 10, you're going to get 11. So that's why I use less than, so that it will not include the 10. Instead, it will stop at 9, right? So here I will now say I plus plus, right? So now I have this. So the next thing is for me is to create the second loop, which is going to keep track of the what? Of the column. So I will say for, in this case, I will say j is equals to 0. The condition is the same because we also have 10 rows, right? 10 columns, right? Then j plus plus here, j plus plus, isn't it? So what's the next thing we need to do? So in this case here, this is where we need to do the work, isn't it? So how do we get the content here, this element here? So what happened is that when you look at this, for the first iteration of I is 0, right? It will check, is I less than 10? Yes, I is less than 10. So 0 is less than 10. So it will jump into this loop. So it will now check for j. J is equals to 0. It will check, is j less than 0? Yes, j is less than 0. So how can I get this element here? I can simply say I times j, which will give us what? Which will give us 0. This will give us the first element here. So j will now increment to what? To 1, right? So it will become what? 0 times 1, because I'm just doing something like this. Let me declare another variable. I think it will be better, you understand it more, if I say result. For instance, this is going to store the result of the multiplication. So if I say result is equals to I times j here. So what is going to happen here is, for the first iteration, I is 0, right? So, and this condition is true. 0 is less than 10, so it will jump into this loop. So it will now begin from j is equals to 0. So it will check 0 is less than 10. This condition is also true. So I'm now multiplying I and j. What is the value of I? I is 0 and j is 0, right? So that is why we are having what? This 0 here. So if j increments now, right, j will now increment to 1. it will now multiply. I is still 0, don't forget. 0 times 1 is still 0. That's why we're having this 0 here. J will increment to 2. 0 times 2 is still 0. That's why we're having this here. Okay, that's how it will go until this condition becomes false. When this condition becomes false, I will now increment because it is going to jump out of this inner loop, and I will now increment. So if it increment I will now become what? 1. Right? So 1 is less than 10. Yeah, it is true. 1 is less than 10. So it will jump into this loop as well. Right? So it will now start from 0. Is 0 less than 10? Yeah, 0 is less than 10. Isn't it? So I'm now multiplying I and J. What is the value of I? I is 1. Right? And J is 0 in this current iteration. So 1 times 0 is what? Is 0. That's why we are getting this 0 here. Right? So J will now increment to what? To 1. As J increments to 1, our I is still 1. Right? So it will become what? 1 times 1 now. Right? That's why we are having this 1 here. J will increment to 2. I is still 1. J 1 times 2, we get 2 here. J will increment to 3. 1 times 3 is still 3. This is how it will go up until it reaches what? 1 times 9. Right? So when it reaches 1 times 9, the next iteration for J, this condition will not be true because it will be 10. So, and we said it has to be less than 10. So it will jump out of this loop and it will increment the value of I. Right? I will now move to what? To 2 now. Right? So it will now check, is 2 less than 10? Yes. So it will jump into this loop. J is 0. It will say, is J less than 10? Yes. So it will multiply 2 and 0. So 2 times 0 is 0. That's why we're having this 0 here. So J will increment to 1. 2 times 1 is what? Is 2. That's why we're having this 2 here. J will now increment to 2 now. Our I is still 2. 2 times 2, 4. This is how we get all the element here. Okay? This is how we get all the element here. I believe this is clear, right? So the next thing we need to do is what? We need to print the result, right? We need to print it. So what do we need to do here? I simply need to say printf. Here, I will just say %d, since I'm printing what? A digit. So I will just say result here, right? So let's try, I think that should be all. No, let's create a new line. So here I will just say printf. After all the loop, we create a new line. So I say printf and /n. All right. So now let's try testing this program. Let me copy the test file. Copy. So vi 9 min.c, right? Okay. I just want to test if it's working before we proceed with Betty documentation. All right. So let me compile the file now. Copy, paste. Okay, it says what? Okay, we've not declared we used printf and we've not declared it. So I need to do #include here. I need to include the stdio header file. We know that that's the library that includes the printf function. So stdio.h. All right, so let's gcc. Oops. Which file did I make changes to? Okay, I made changes to my 9 instead of this. #include stdio.h. Yeah, so I think it's okay now. Let's compile again. Yeah, so let's run the compiled file. Whoa, so as you can see, we are having it jam-packed in one place. So we need to split it. We need to give spaces and line breaks to make it look like this. So let's open the file. So what we need to do first here is this. Just look at this now. Just look at this. There is a space and a comma after each and every character printed, right? There is a space and a comma. So what if I do something like this here? If I should say comma and a space. After printing the digit, create a comma and then create a space, right? So what if I do something like this? I think this will also work, right? So let's try. It's a matter of trial and error. So let's see. Yeah, so as you can see now, it's beginning to make sense, even though not that much, but it's better than the above output we got. So the next thing is for us is to break it. It means whenever it reaches the end of one iteration, we should break a new line. So don't forget, this keeps track of what? I keeps track of the row, right? So it means that before I increment to this next iteration, we need to what? Create a line break. We need to go to a new line before I increment. So here I need to add my printf is supposed to come here. I need to say printf, yeah, so I need to say printf here, and then I will add what, a backward slash n. So this is going to break to give a new line before I increment. So let's see what we'll get now. So that's /9. Yeah, so as you can see now, it's beginning to make sense, right? It's beginning to look something like this exactly. So that's how we keep modifying the code. So as you can see here, I have a space. So I think this is because of this line here. I'm not supposed to leave a new line here. Let me remove this. Yeah, there's not supposed to be a new line here. So let's compile again and let's run. Yeah, so as you can see now, we don't have the space. But when you look at this as well, from this side here, it is kind of bent, right? So we need to what? We need to make it aligned. Let it be aligned with each other. So what happened here, as you can see, is that here, each and every character here is given a space to occupy 2 digits, right? So that's why they are kind of aligned in one place. Even the ones with single character here, single digit, they are given space to what? To accommodate 2 characters, just like this one. This one here is given a space to accommodate 2 digits, and it's still hosting 2 digits. This one as well, this one as well. But for these ones, they have the chance to accommodate 2 digits, but they are just storing 1. So what we need to do is we need to provide, or we need to make all these digits to have what? 2 spaces. It means they can accommodate 2 digits, just like this one. That way they will be able to be aligned. We can align them, right? So all I need to do is I need to open my file. So here I will just say, instead of saying %d, I will just say %2d. So this is going to give 2 spaces, okay, for each of the characters. So let's see. Let's compile GCC. So let's run it. Yeah, so as you can see, we got something. It is kind of aligned, right? But this comma at the end, we don't need it. As you can see here, there is no comma at the end, right? So we need to what? Remove the comma at the end. And also when you look at this here, there is a spacing before the 0. There is a spacing before the 0, and here there is no spacing. So we need to what? Get rid of the spacing at the beginning and also the comma at the end, right? So we don't need that. So I need to modify the code a bit as well. So all I need to do here is I need to set a condition first, right? I need to set a condition. So one thing you need to take note here is that it is only this 0 here that I want to remove what? The spacing before it, right? Just in the previous example, in the output we got, it is this line here, the line which contains the 0 here, that is having a space before the digit. So we need to what? We need to get rid of it, right? We need to get rid of it. So what I'm going to do here is I need to modify the code. I will say if J is responsible for what? For the column, right? And it is this column that I want to remove. Sorry, it's highlighting everything. This column that contains all 0, it is this column that I want to remove what? The spacing. So I'll just say if J is equals to 0, that means all this column here, this is the column that contains all J is 0, right? So if J is equals to 0, what should we do? If J is equals to 0, I don't want to what? I don't want to leave a space, isn't it? I don't want to leave a space before it, and I don't want to give it two space. I don't want the 0 to accommodate 2 space. Okay, all just like this one, all like this one I did here. This one I did here, as you can see, the result is going to be printed and it's going to have 2 spacing. But if it is if it is 0, if J is 0, I don't want it to accommodate 2 space. Instead, it should accommodate 1. Okay, because I want to get rid of the spacing that comes before the 0, isn't it? So what I'm going to do here is I will just say printf, right? So here I will just simply say %d. I'm not going to add any 2d here. I'll just say %d because I don't want an extra space to be given to this first row, first column here, which contains all 0. Do you get it? So I'll just add what? A comma and a space. So a comma and a space will be printed, right? Just one space is allocated to all this column here, this one containing 0, and then after printing it, print a comma and the space. So the next thing is what? Pass the parameter that holds the value, which is what? A result, right? So here, now the next thing I will need to do here is I will just say else, right? I will say else, else This means that what? If J is not equals to 0, if J is any other value not equals to 0. So if it is not equals to 0, then we can give it what? 2 space, and we can give it the chance to accommodate 2 space, right? So I will just need to say printf. It is the same thing we just did above, or sorry, below, percentage D, sorry, 2D here. Then what again? Then I will pass in the variable result, right? So now I have this set. So I need to get rid of what? Of the comma that we always get at the end, right? If you remember the output, let me just display this for you so that you can see it again. If you remember here, we are having a comma at the end. So now I need to get rid of it, right? So how can I get rid of this comma here? So all I need to do here is, you know that when J is the last character here, this is what value is responsible for keeping track of these columns here? The column is J, right? So in all this column here, that is the last column, I don't want to print a comma, right? I don't want to print comma in the last column. And what will be the last column? Since we know that our J is going to stop at what? At 9. So definitely the last column is 9. So I can set a condition to target the last column. So all I'm going to do here is I will just say if, inside this else part here, I will just say if my J now, right? Don't forget this else part is targeting value that is not equals to 0. So here I will just say if J is not equals to 9. So only if J is not equals to 9 that I want to print a comma and the space in the digit, right? If it is equals to 9, if J is equals to 9, don't print it. So here I will just say printf, then I will just say comma and then space. So this is going to print a comma and the space after every digit, excluding what? The digit in the last row. That is why I said J not equals to 9, because the last row here is what? Definitely 9. That is row 9 here, right? This is row 9. If you count from 0, 1, 2, this is row 9. Sorry, column 9. So I'm targeting everything excluding column 9. So if my J is, that means if we reach the last column, which is column 9, don't print this. Only if we are in other columns, that is when you need to print what? The comma and the space after printing what? The value. Do you get it? So let's try compiling this now. So GCC, let's run it. Yeah, so as you can see, we got it corrected. We don't have the comma and the space in here. So as you can see here, they are having a $sign. So initially I thought it was part of the code, but it is not. You can go and find out about this cat.e, what it does. So let's just run the command here and see. You are going to get our $. Did you see that we also got the $, at the end? Okay, so let's test this command as well. Copy this and paste. So let's run it. So as you can see, we got exactly the same thing here. It's exactly the same thing. Okay, so don't forget to add, commit and push to your GitHub repository, and then you can run your checks. Okay, so now let's move on to the next task. So this task here says we should write a function that adds 2 integers and returns the result. So let me copy this. I already have the function prototype also inside my header file, so I'm going to paste this here. All right, so hash include our main.h. So it says that add 2 integers and return it. So you should just add the 2 integers and it should also return the sum of the addition, right? So here, don't forget, here we need to give it a variable name. So let me just say A and what? And B. Okay, like I said earlier in the beginning of this video, I said in the beginning of this task, I said it doesn't matter if you leave your prototype without the variable name A and B. As far as the data type is there, you don't have any problem. So here, what should I do? I will just simply say return what? Return A plus B. That's all I need to do here. I'll just say return A plus B. That's all. So this is simply a function to add 2 numbers. So let's document Betty. In the previous task, I forgot to document Betty. I think we're going to do that. So here, I will just say add. So function, right, that sums 2 numbers, right? And then the next thing is what? The parameters I need to explain to Betty. At A, let me just say parameter 1. And then the next one, sorry, shift, wow. This is at what? B, so I will call it parameter 2, right? So I will just say, what is this returning? return a plus b, right? The sum. So I think that should be all. So let's run Betty 10 add.c. Yeah, so Betty is happy. So let's compile this program. Sorry, let me create the test file. So vi10 main.c, right? So paste this, add my hash. All right, so let's compile this and let's test. So paste. All right, set. It has been compiled. So let's run the compiled file. So as you can see, we got 98. This is the parameter passed to the function 89 and 9. So 89 plus 9 is going to give you 98. Okay, so now let's document the above code. For Betty, we forgot to do that. 9. I'm sure you guys can even do this yourself. Sorry, I opened the compiled file. So vi 9 times table.c. Right, so here I will just need to say, right, so what's the function name? It's called times table, right? So print, right, 9 times table. That's what the function does, right? So it has no parameter, so I simply just say return what? Let me just say return 0. So as you can see, the function is void, so we are not supposed to return anything to the function because it is void, right? And also the parameter here is void, so it's not going to take anything as parameter. So now let's run Betty on it. Betty 9 times table. Okay, do not abet to be unified div format patch. What are we? Okay, sorry, Betty 9 times table.c. I missed that. Okay, so as you can see now, Betty is happy. So this is simply the Betty documentation for this task, and also we've done that for this task as well. So don't forget to add, commit, and push to a GitHub repository, and then you can run your check. So this says we should write a function that prints all natural numbers from n to 98 followed by a new line. So before I proceed, let me open my header file for you so that you see what I have inside my header file. Sorry. Yeah, so this is my header file. I already have this function prototype inside this header file. Okay, so let's begin writing the code. So it says we should write a function that prints all natural numbers from n to 98 followed by a new line. This is the prototype. Numbers must be separated by a comma followed by a space. Numbers should be printed in order, and the first printed number should be the number passed to your function. The last printed number should be 98. You are allowed to use the standard library. So all what this question is asking you to do is simply to write a function that is going to print numbers from n to 98. Whatever is passed as the value of n in the function parameter, the function will start printing from that number up to 98. Okay, so let's look at the example here. So as you can see here, 0 was passed to the function. So we got from 0 up to 98 printed. So the next call to the function, 98 was passed to it, so we got 98 printed. The next call to the function, 111 was passed to the function, so we got 111 As you can see, it is now printed in reverse up to 98. So the next call, 81 was passed to the function, so it will print from 81 in reverse as well up to 98. And then a -10, it will print from the minus up to 98. So whatever is passed to the function as the argument, you need to print the numbers from that particular argument up to 98. 98 is the last number you are expected to print. Your function is expected to print. Okay, so now let's see how we can write the solution to this problem here. So let me copy. So vi paste. All right, so we need to include our header file, right? Let me zoom my screen. Yeah, hash include main.h. Right, so the function prototype, copy, paste. All right, so what's the first thing we need to do here? As you can see, when you look at this, we have 4 conditions to consider. Right, we have 4 conditions to consider. The first condition we need to consider is if the value of n is greater than or equals to 0 and also less than or equals to 98. That is this value here, the first case here. If the value is greater than or equals to 0 and also the value is less than or equals to 98. So I need to set a condition for that. So all I need to do here is I need to say if, or before that, I'm going to need a loop definitely somewhere. So I will declare the variable that I'm going to use for my looping. So after that, I will just say if what? If n is greater than, if n is greater than or equals to 0, and also n is less than or equals to, I used m, n is less than or equals to 98. So now I've targeted any number that falls between 0 and 98. When you look at this, we have 4 conditions here to check for. Is either the value of n is greater than 0 or less than, and also less than 98, or is either the value of n is exactly 98, or is either the value of n is greater than 98, or is either the value of n is less than 0, that is negative. So that's why I said we have 4 conditions to check for here. So if n is greater than or equals to 0, and also n is less than or equals to 98, what do we need to do? So we need a loop, right? We need to loop over from where? From n, since they said our function should start printing from whatever the parameter is passed to it. So we are going to start printing from n up to where? Up to 98, because 98 is the last number we are expected to print, or our function is expected to print. So I will say for I here is equals to what? N, my iteration, my initialization. I'm starting from n. So what should be the condition? I should be less than or equals to what? 98, because 98 is the last number our function should print. Then what? Then I plus plus. So now we have this for loop. So what do we need to put inside this for loop now? So inside this loop, we need to print what? The value of I, right? We are going to print the value of I. So I need to say printf percentage d, right? Then comma I. So whatever the value of I is, it is going to print it. So this way we will have numbers from n up to what? Up to 98 printed. Okay, we'll have from n up to what? Up to 98 being printed. But what's the next thing we need to do after this? So after printing this, we need to go to a new line, right? After printing up to 98, then we need to go to a new line. So I'll just say printf, then I will add in a backward slash n here. So it means that after generating this set of numbers here, it will go to a new line. Okay, it will go to a new line. So that's what I'm just trying to do here. So the next condition to check for is what? Is else if the value of n, right? If n is what? Is less than 0. That is if n is negative, isn't it? We need to check for that. If n is less than 0, just like this case here, if n is less than 0. So if it is negative, what do we need to do? So we need another loop here as well. So we'll just say for I equals to n. We are also starting from n as well. But what should be the condition here? If it is less than 0, the condition is still I has to be less than or equals to what? Or equals to 98. Right? So what should be the condition? The condition should be I plus plus. Right? So it is going to start looping from n, whatever the value of n is, and also it has to be less than or equals to 98. I has to be less than or equals to 98, and then I plus plus. So what do we need to put inside our for loop here? So inside this for loop, what do we need to do? We need to print the value of I as well, right? So I just say printf, then percentage d, then I'll pass in I. So after the for loop, sorry, I missed a semicolon here. Alright, so after the for loop here, I will simply printf a new line, right? So backward slash n. So now I have checked for what? N less than 0. Isn't it? I've checked for n less than 0. So the next thing I need to check for is n is greater than what? Else if n is greater than 98, that is this part here. If the value passed is already greater than 98, so it means we are going to start from the largest and we'll be decrementing. Instead of incrementing our loop, this time we'll be decrementing it. We'll be decrementing it up to what? Up to 98, right? So here I will just say else if n is greater than 98. So if it is greater than 98, this is what I want to do. So I simply need a for loop. I'll just say for I equals to n. I'm starting from n. What should be the condition? What should be the condition here? The condition is going to be I greater than or equals to 98 in this case. Why is it I greater than or equals to 98? Because as you can see here, the values are all greater than 98. Right? The values are all greater than 98 here. So that's why I said greater than or equals to 98. In other cases, as you can see, the values are less than 98. So here we are starting from the largest. right? The numbers we are starting from is larger than 98. So that's why I said I has to be greater than or equals to 98. So the moment it reaches any value apart from 98 or a value less than 98, it will not print it. Okay, this loop will not be considered. So what do we need to do here? We're starting from the largest. So the next thing we need to do, instead of incrementing here, we simply need to what? Decrement. We say I minus minus. Because what? We are starting from the largest up to what? Up to the smallest. So here was the next thing we need to do. So here we simply need to say printf. We now print the value, which is %d, I here. Right? So outside the for loop, I will now create a new line. So I'll say printf, then /n. All right. So let's try testing this program. I think that should be all. Greater than 98. No, we need to check for if it is equals to 98. So else if, sorry. So I need to say else if n is exactly equals to 98. If n is exactly equals to 98, what do we need to do? We just need to say printf %d. We are just going to print the 98, right? Just like what happened here. The value passed to it is exactly 98, so we just need to print it, right? So I just say %d /n. It should just print a new line after printing it. Then I will just say what? N here. The variable that is holding what? 98. So I'll just say n. So this way I will print what? The exact 98 digit, right? So let's test this program and see. So let me create the test file, which is 11 min.c, right? So copy this and paste here. So I need to make the correction here, #i. All right. Okay, so let's compile the program and see if we will get the desired output. So paste this, compile. Oops. So printf incompatible implicit declaration. Okay, seems like I've not included my stdio.h header file in my function file. So here I need to say #include stdio.h. Right, so compile again. Yeah, so it has been compiled now. So let's run the compiled file. Whoa. So as you can see, we are getting it kind of mixed up. As you can see, we are having from 0 to 98 here. We are having 98 from 111 to 98 from -90. As you can see, it's starting to make sense, right? So all we need to add now is the comma and the spacing, right? So I just need to open my file again. So all I need to do here is, for the first case here, we consider the first condition, I need to add what? After printing the value, we need to print a comma and the space. So here, I will just say what? I will just say, I can just add comma and the space here. So comma and the space. So after printing the digit, add comma and the space. So here as well, after every printf %d, I'll add a comma and the space, also comma and the space here. So this way I'll have comma and the space printed, right? So in this case, I don't need to add it because 98 is the only character I'm printing. So there is no other, it is the only digit I'm printing, no any other digit that will follow. So there's no need for a comma here. So I will just compile again. So let's run the compiled file. Yeah, so as you can see, let me zoom out a bit. Yeah, so as you can see, we are having something here. Or let me run it again here. Yeah, so as you can see, we're having from 0 up to 98. We are having 98, and we have 111 to 98, and we have from -10 here to 98. But notice something, that we are having a comma at the end of all these things. So we need to get rid of the comma. Right, we need to get rid of the comma. So we need to modify our function in such a way that it will not add a comma and the space at the end of the last digit, right? So all I need to do here is I will simply set a condition here. Instead of adding a comma and the space beside my %d, I will just set a condition here. Sorry, I will just say if my value of I, right? If the value of I is not equals to what? 98, because 98 is the last character, last digit we are printing. So as far as my value of I is any other value apart from 98, then I want to do this. I'll just say printf, right? I'll just say printf, comma, space. So this way, it is only going to print a comma and a space when I is not equals to 98. So this means that when I reaches the last digit, which is 98, it is not going to print a comma and the space. That's why I use not equals to 98. So any other digit that I is holding, it will print it unless if I is equals to 98. So if it is equals to 98, that means it is the last digit, so no need for a comma and the space. Okay, so that's the same thing we need to do here for the rest as well. So here I also need to say if I is not equals to 98, right? So if it is not equals to 98, printf, so comma space, right? So same applies to this last part here. So I simply need to remove this comma and the space here and add the if statement. So I'll just say if I is not equals to 98, right? So if I is not equals to 98, printf, and then what? Comma and the space. So this way I will have my comma and the space printed only after digit that is not 98. Okay, after a digit that is not 98. If the digit is 98, it will not print the comma and the space. So this way I will have the comma and the space removed after the last digit. So now let's document Betty. So what's my function name? Function name is print to 98, right? Then let me just say print numbers from n to 98, right? That's what the function does. So what else? At n, it takes in a parameter, right? So at n, let me just say number to start from, right? Number to start from. So what next again? Return, right? So we need to say return. Our function is void, so it's not supposed to return anything, so I'll just say 0 here. Or let me just say return is void. So here, then I think this is fine. So let's run Betty first. Betty 11 print.c. Yeah, so Betty is happy. So let's compile the program again. Yeah, it has been compiled. So let's run the compiled file. Yeah, so as you can see now, we got the comma not present in the last characters, right? We don't have commas in the last character here. So after 98, there is no comma that is following. Sorry, the last digit. After 98, there is no any comma following, right? So it means that we have successfully gotten rid of the comma at the end of what of our digit. So don't forget to add, commit, and push your GitHub repository, and then you can run your checks. So today we are going to begin from task 13 of the project. So it says if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. So the sum of these multiples is 23. Write a program that computes and prints the sum of all the numbers, the sum of all the multiples of 3 or 5 below 1024 excluded. So 1024 is not going to be included, followed by a new line. You are allowed to use the standard library. So in summary, all what this question is saying is that if you list the multiples of what of 3 or 5 below 10, that is any number below 10 that can be divided by 3 and also, or let me not use and, that can be divided by 3 or 5, right? So if you sum these multiples, you are going to get the total number of what? 23, right? So the multiples of 3 or 5 below 10, we know we have 3, we have 5, right? We have 6, and we also have 9. So if you sum these numbers here, you are going to get 23. Right? So it says we are to write a program that computes and prints the sum of all the multiples of 3 or 5 below 1024 excluded. So here they just gave us what? The sum of what? The multiples of 3 or 5 in numbers less than 10. So now we have to find the multiples, the sum of multiples of 3 or 5 in numbers less than 1024. Okay, so let's see how to do this. So firstly, let's work on their own. Okay, let's try finding out if this 23 is really the sum of multiples of 3 or 5 in numbers below 10. Okay, so let's do this, right? So in this case, we are not writing a function, we are writing a program. So all I need to do is just include my stdio.h, right? So I will just say int main, right, void. All right, so what's the first thing we need to do here? I need to declare a variable which is going to hold the sum. So I'm going to call it sum, right? So and then what again? I need to, let me initialize it to 0 since I'm going to sum something, right? I'm going to initialize it to 0, so it's going to start from 0. Sum is now holding the variable 0, sorry, the value 0. So the next thing is I need to declare my I, which I'm going to use for my looping, right? So the first thing I need to do is, here they said from numbers below 10, so it means we are going to count from where? From 0 to what? To 9, right? Numbers below 10, 0 to 9, or from 1 to 10. We are going to count from 1 to 10, since 10 is also a multiple of 5. So we are going to count what? From 1 to 10. So I'll just say for I equals to 1, right? So what should be the condition? I less than or equals to 10, right? Then I plus plus. So now this is going to loop from what? From 1 to 10. So what do we need to do inside our for loop here? So inside our for loop, we need to check if the value of I is what? A multiple of 3 or 5. So if it is a multiple of 3 or 5, it means that if you divide the number by 3 or by 5, the remainder will be 0, right? So all I need to say is if I modulo 3 is equals to 0. Now I'm checking for what? Multiple of 3. If the number of I is a multiple of 3, that is for each iteration of I. Or if the value of I modulo 5 is equals to what? Is equals to 0. So now I'm checking for what? Multiple of what? Of 5, right? So if any of this condition is true, what do we need to do? I'll just say sum. I need to update the value of sum now. So I just say sum is equals to sum plus what? Plus I. So what I'm doing here is, initially sum is 0, right? So sum here is storing 0. So what I'm saying is that sum plus what? The I, right? So if that I, you know that this part here will only be executed if one of this condition is true. If either I modulo 3 is equals to 0 or I modulo 5 is equals to 0. So if one of this is true, then it means that we found a multiple of either 3 or 5, right? So if we found the multiple, we are told that we need to what? Sum them, right? So now that's why I said sum plus what? Whatever the value of I is, since that value is a multiple of what? Since I 3 and 5 are multiples of that value of I, right? So I'm now adding it to sum. Initially sum is 0. If I increment to the next iteration as well, if the condition is true, then it will perform this same summation here, and the value of sum will now be updated, right? So for each iteration, and if the multiples of 3 and 5 is found, then it will update the value of sum. So if it is found again, then the multiple of sum will be added to what? To the value of I. So this way we'll have the values of sum being updated. So for each multiple found, it is going to add it to the existing value of sum. So this way we are going to have the total summation of the multiples of numbers below 10. Multiples of 3 and 5 below 10. Okay, so that's all we need to do about this function here. So the next thing we need to do is what? I need to print. It says well, write a program that compute and print. So here I will just say printf, right? I will just say printf %d /, and then I will pass in what? Sum. So because sum is the variable that is holding the summation of what? Of the multiples, right? Is sum that is holding the summation of the multiples. So let's test this program now. So I'm just going to compile it using the simple GCC flag. I'm not going to add all those whatsoever. So I just say GCC. What's the file name? 101 natural.c. So let me call it 1 here. As you can see, I just used the simple GCC flag. There is no need for us to use those wall extra in this case. As you can see, it is not even compiled here, right? We just want to test if it is working. So I call it 1. So let's compile, or let's run the compiled file. So as you can see, we are getting 33 here instead of 23. So definitely we are missing something somewhere. So let's open our file again. So what is the possible reason why we are having this? I think here I can simply make this a 0. If I say 0 here, okay, when you look at this, it says what? Below 10. Numbers below 10. So it means 10 will not be included here. So I will just say 0 and I will say less than 10 here. I'm starting from 0 and say less than 10. So this way I'm considering values that are less than 10. So let's compile again. So GCC So as you can see, we got the value 23 now. So it means this is correct. So all we need to do now is change our 10 to 1024 here, right? Since we are considering values less than 1024. So I just need to open this and add 1024 here, right? That's what we are checking for. We are checking for 1024, not 10. So here, if you compile again, run the compile file, as you can see, we got this. So this is the summation of the multiples of 3 and 5, or 5 in numbers that are below 1024. All right, so now let's document Betty on our code 101. Yeah, so here we just say main, right? Main, let me just say function to sum multiples of 3 or 5 in numbers below 1024, right? So that's what the function does. So I'm supposed to return it actually. So I just say return 0. That's what the function returns, right? It returns a 0. So here I simply need to come down here and add my return statement here. So I'll just say return 0, right? So it's returning 0. So save, exit. So let's run Betty 101. Okay, trailing white space in line 17. All right, so let's see which one is line 17. So set number. Okay, this is line 17. So okay, line, yeah. So let's save, compile again. Sorry, Betty. Yeah, so Betty is happy with this, so we can now compile again and then we can run it. So as you can see, we're getting the same value here. So this is simply how you can solve this task here. Don't forget to add, commit, and push to your GitHub repository, and then you can run your checks. So this task here says we should write a program that prints the first 50 Fibonacci numbers starting with 1 and 2 followed by a new line. The numbers must be separated by a comma followed by a space. You are allowed to use the standard library. So for us to solve this problem here, we need to first understand what a Fibonacci number is. What are Fibonacci numbers? So let me give you an example of what Fibonacci numbers are. Assuming I have these numbers 1, 2, 3, 4, and then 5, right? Assuming I have 1, 2, 3, 4, and 5. So I want to find the Fibonacci of each of these numbers here. So the Fibonacci of 1 is definitely going to be 1. You just bring it down, it's going to be 1. That of 2 as well is just going to be 2. So now, to find the next Fibonacci number, you simply need to sum up the 2 previous numbers. So in this case, if I want to find the Fibonacci of 3 here, it is simply going to be what? 1 plus 2, which is going to be what? Which is going to be 3 here. Right? So now if I want to find the Fibonacci of 4, I need to sum 2 and 3. Right? So 2 plus 3 is what? Is 5. So the Fibonacci of 4 is what? Is 5. So if I want to find the Fibonacci of 5 now, I simply need to sum up 3 and what? And 5, which is what? Which is 8. So assuming I have 6 as well here, I have 7, and let's say I have 8 here. Right? Assuming I have all this now. So if I want to find the Fibonacci of 6, what am I going to do? I'm going to sum up 5 and what? And 8. So 5 plus 8 is going to be what? Is going to be 13. Right? So now I want to find the Fibonacci of 7. What do I need to do here? I simply need to sum up what? 8 and what? 13. As you can see, I'm summing up the 2 previous numbers. Right? So 8 plus 13 is simply going to be what? 21. Isn't it? Yeah. 8 plus 13 is going to be 21. Forgive my handwriting. So this is what? 21. So 21 plus 13, that is, I'm not trying to find the Fibonacci of 8. 21 plus 13 is simply what? Is simply going to be 34. So this is how you find the Fibonacci sequence of a number. As you can see, you just need to sum up the 2 previous numbers. So for the first number, 1 and 2 in this case, you just need to bring it down. 2. 1 and also 2. Okay? This Fibonacci here can vary. Okay, assuming you are asked to start from 4. So 4, 5, 6, 7, and 8. So in this case, you need to bring 4 down here and also 5 down here. So 5 plus 4 is 9. So in this case, Fibonacci of 6 is going to be 9. So that's why I said it is changing, right? So to find the Fibonacci of 7, in this case, is going to be 5 plus 9, which is going to be 14. To find Fibonacci of 8 is going to be 9 plus 14, which is simply going to be what? Which is going to be 23. Right? Isn't it? Yeah, 23. So this is just how to find the Fibonacci of a number. I'm just trying to give you an insight of how this is going to look like. So how do we begin solving this problem here now? But before we proceed, let's explain this first. I said we have 1 initially, we also have 2, we also have 3, 4, and 5, right? That's what we have initially. So we said the first thing we need to do is we need to print what? The first character, the first digit, 1, right? So let's follow this step by step. So what I'm going to do here is, let me open the file first. We are going to do it step by step, okay, so that we will get the idea about this. So it's a program, so I need to just include my stdio.h. Let me maximize a bit. Yeah, so I think it's better this way. So int main, and then this is void. All right, in fact, let me, since my function is not taking any parameter, I think I can document Betty now, right? So let me just document Betty. I will just say program to find first 50 Fibonacci numbers. I think it's okay, right? Then what again? Then the return is just going to return 0. So this and this. So here I will just say return 0. All right, so what's the first thing we need to do here? The first thing we need to do here, like they said here, that we should what? Print the first 50 Fibonacci numbers starting with 1 and 2, right? I've already explained this here. So we need the first and the second, right? So these are going to be, these two numbers here will not change. Okay, 1 is going to be 1, 2 is going to be 2. Now that we have two numbers, then we can add them to get the third number, right? So that's why they said we should start with what? 1 and 2. So I'm going to declare a variable to store this 1 and 2. Okay, so I'll just say int, right? Let me call it first, right? Or let me call it term 1. Just call it term 1, right? Is equals to what? Is equals to 1, right? And then declare the other one, which is term 2, right? Term 2, which is equals to 2. Yeah, so now I have this declared. So the next thing I want to do is I need to declare a variable that will hold the summation of the numbers. Right now I have a variable to hold 1. I also have a variable to hold 2. So now I need a variable that will hold the summation of 2 and 1. Right? So I'm going to call it next. Right? Let's say next. Yeah, I think it's more descriptive. Let me call it int next. So this is going to hold the what? The next value. Okay, it's going to hold the summation of 1 and 2, which will give us the next Fibonacci number, isn't it? We've seen how to do that. So what's the next thing we need to do? We said the first thing we need to do is we need to bring down this, right? The first digit here need to be printed first. So here I will simply say printf. So I'll just pass in percentage %d here, right? I'll just pass in percentage %d, and after printing the first number, as you can see, they said followed by a space and a comma. So I need to print what? A comma and what? And a space here. Do you get it? So now I have a comma and a space here. So what do I need to pass here? This is going to be what? I'm going to print term 1, right? So I'll just say term 1. So now I'm going to have this 1 here, right? As the first Fibonacci number, isn't it? So the next thing I need to do is I need to loop from that particular 1 up to what? Up to 50, because they said first 50 Fibonacci number, right? So I need to declare a variable I for my looping, right? So let me call it I here, or let me just declare it above here. So it's going to be int I. So here I can simply go for my loop. I will say for I equals to what? I'm starting from what? I'm starting from 1, right? 1 to what? 50, first 50. So this is going to be I less than 50, then I plus plus. So this is going to look from 1 to what? To 50, isn't it? So what's the next thing we need to do? Inside my for loop here, inside this for loop, the next thing I need to do is to print this second number here, because I said we need to print the second one as well, right? After printing the first one, we print the second one, right? So here I will also say printf, right, %d, isn't it? And then what again? Comma, then I will just say term 2. So now I have the second term printed. The first term is printed, and also I have the second term printed. So what is the next thing we need to do? The next thing we need to do is to find the value that we are going to place here. And how do we find this value? We need to sum up what? Term 1 and what? And term 2. Isn't it? We need to sum term 1 and term 2 to give us what? To give us the value here. And the value here is going to, and the variable that is responsible for storing the summation of term 1 and term 2 is what is next. And that next is going to give us the Fibonacci at this point here, right? So all I need to do here is say next is equals to what? Term 1 plus term 2. So now I have term 1 plus term 2, which will give me the what? The value at this point here, right? The Fibonacci value at this point, isn't it? So now I have this at this point now. So what the next thing I need to do? The next thing I need to do is I need to update these two numbers here, right? Assuming here 1 plus 2 is 3, let's say my next is now storing 3 here. So you know that I need to update what? The values of 1, 2, and 3. Now, initially this was what? Term 1, right? This was term 1, and then this one is what? Term 2, isn't it? Initially, right? So now I need to update it, because now I'm considering what? To get the Fibonacci at this point, I need to sum 2 and 3, right? So it means this 2 now, that was initially term 2, is going to be what? Term 1 now. And this 3 here, right, is going to be what? Is going to be term 2. Isn't it? As you can see, it has been updated. So this is the two numbers I'm adding. So that's why I need to update what? Term 2 to be term 1. And then next here is going to be what? My term 2. I hope you understand this, right? Initially, this is term 1, and this is what? Term 2, my first two numbers. So now that I have next, I want to find the Fibonacci at this point. I need to sum these two numbers, right? I don't have any concern with this one here now. My concern is this 2 and 3, right? So it means that my term 1 now is this 2 here, which was initially term 2. And my term 2 here is this 3, which was initially what? The next. Isn't it? Because it is a summation of 1 and this 2, right? So I need to update them now. So all I'm going to do here is I will say first, term 1, I use term 1, right? So term 1 is now equals to what? Term 2. I've already explained that, right? Term 1 is now equals to term 2. Initially, this is what? Term 2, isn't it? Initially, this is term 2. So now I'm saying term 1 is now equals to the initial term 2. So now it is pointing to this. So the next thing is what? Term 2, my term 2 will now be what? My term 2 will now be equals to this next, because it is a summation of 1 and 2, right? So I will now say term 2 now. I'm updating the values. So term 2 is equals to what? Is equals to next. Isn't it? So this is simply how you can find the Fibonacci of a number. So here I will simply need to say printf for a new line /n. Okay, I hope you understand what I just did. I've already explained what Fibonacci is, and I've explained how we get the Fibonacci of a number, right? So for each iteration, we need to update what? Term 1 and term 2, isn't it? For each iteration, term 1 and term 2 need to be updated. So assuming now my next is what? 3 plus 2 is 5, right? Assuming I'm having 5 here. So what will happen? So this 3 now is now going to be what? My term 1, isn't it? And this next here is going to be what? My term 2, right? And whatever I find as next is going to be stored here. That is summation of 3 and 5. That's why I said the value of term 1 and term 2 will keep updating. Okay, as we're moving, it will keep updating, right? So now I have my term 1. This term 1 that I'm having now is initially term 2, isn't it? Previously, in the previous iteration, it is term 2. So now term 2 is now equals to term 1. That's why I set this here. Term 1 equals to term 2, right? And term 2 now is now what? What is term 2? My new term 2 now here is what? Initially, in the previous iteration, it is next, because it is the value that holds the, sorry, it is the value that was gotten from the summation of term 1 and term 2. So I've updated the value now. Term 2 is equals to next. I hope you get this. So let's try compiling this. So GCC, before that, let me run Betty. Betty, what's the file name? 102 Fibonacci, right? Yeah, so Betty is fine. So GCC 102, so dash, let me just call it 2. All right, so let's run it. So wow, we're getting a negative here. So I think we're getting this negative because the size of int, the value we are passing, has exceeded the size of int. So int is not, it cannot be able to accommodate that. I think we can use unsigned long int. I think this should be able to accommodate the large number. Okay, the number we are having has exceeded the amount that the numbers that int is going to handle. That's why we are getting that negative. So if I should say unsigned long, you can find out more about this data type. We've already talked about data type, right? This is part of the basics we've talked about in C programming. So I think what's next? Our next is going to be unsigned long as well. So our I can still remain the way it is. So I think then I need to change this. Instead of D, this is going to be LU, since it is now an unsigned long, right? So LU here. All right, so let's compile again. GCC. All right, so let's run the compiled file. Wow, so we're getting the values, but the issue we're having here is we are not printing comma and the space in the remaining part. As you can see, we have a comma and a space in the first iteration, sorry, in the first digit here. So the remaining digit has no comma and the space, and this is the reason. Here we've set comma and the space to be printed after printing term 1. That's why it is only term 1 that is having what? Comma and the space. So to have comma and the space in the remaining characters, all I need to do here is I will now set a condition here. I will say if I is not equals to, what is the last character here? I'm looking from 1 to what? To 49 here. As you can see, 50 is not included. So if it is not equals to 49, I is not equals to 49. The reason why I'm using not equals to 49 because I don't want the comma and the space to be printed at the last, after the last digit. Okay, so if it is not equals to 49, then I'm going to print what? My comma and the space. So this way I will have comma and the space printed after every digit except the last digit, which is going to be 49. Do you get it? Not the last digit except for the last iteration, which is going to be 49. Do you get it? So whenever I is 49, so the value, the Fibonacci of 49 will not have comma and the space printed. Okay, so now let's compile this again. So let's run it. So as you can see, now we have it. Did you see that we don't have any comma and the space at this point here? But in the remaining part, we have the comma and the space. Okay, so this is simply how you can find the Fibonacci of a number. I believe this is clear, right? So don't forget to add, commit, and push your GitHub repository, and then you can run your checks. So today we are going to continue from task 15 of the project. So this is each new term in the Fibonacci sequence is generated by adding the previous two terms. Yes, we realize that to find the next term of a Fibonacci, we sum the two previous numbers, right? So by starting with 1 and 2, the first 10 times will be 1, 2, up to what? Up to 89. That is the Fibonacci of what? Of numbers below 10, the first 10 Fibonacci numbers, right? So by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, write a program that finds and prints the sum of the even valued terms followed by a new line. So now what this is saying is that we are going to check for the Fibonacci's that do not exceed 4 million. And in this Fibonacci that do not exceed 4 million, we are going to write a program that will find and print the sum of the even valued terms. So it means that we need to divide this by 2. right? If the remainder is 0, it means what? We've found an even number. So we need to what? We need to sum them. Okay, so write a program that finds and print the sum of the even value terms. So we are going to what? Find the even value terms first, and then we are going to sum them. So at the end, our function or our program should print the what? The sum. That's also what this question is saying. So let's see how to solve this. Let me create this. So this is a program we're writing, right? So this is going to be hash include stdio.h, right? All right, so here I'll just say int main, and then I'll pass in void. So here I think I can just document Betty here. So I'll just say main, let me just say main function here. So the next thing is what? Is return. Sorry, I need to use capital R. So what is this return? Return 0, right? So here and here. All right, so here I can simply say return, and then I'll pass in the 0 as the return value. All right, so now what's the first thing we need to do? Take note that our limit here is what? Is 4 million, right? The Fibonacci sequence values should not exceed 4 million. The Fibonacci sequence, they are not saying that we should what? We should find the Fibonacci of numbers from 1 to 1 million. No, this is the sequence, that is the Fibonacci itself. Okay, the Fibonacci should not exceed 4 million. Okay, so what we're going to do here is I'm going to create a variable to store this limit here. So I'm going to call it limit. So I would just say int limit. I'll just say equals to what? 4 million. So now I have it stored, right? So the next thing is I need to store these variables 1 and 2, term 1 and term 2, just like the way we did in the previous problem on this same Fibonacci. So I'll call it term 1, which is equals to 1, and then term 2 again, term 2, which is equals to 2. So what's the next thing we need to do? So the next thing is we need to declare a variable next, which is going to store the summation of what? Term 1 and term 2. Right, this will give us the word Fibonacci of the next number, right? So what's the next thing? I'm going to declare another variable. I'm going to call it sum. This is the variable that will store the summation of what? Of this Fibonacci, that is what? That is divisible by 2. It says that write a program that finds and prints the sum of the even valued terms. So the sum of the even valued terms. So I'm going to declare a variable sum here, and even numbers from 1 to starting from 1, which of the number is the first even number we normally see. From 1, the first even number is 2, right? So I'm initializing my sum with what? With 2. Do you get it? I'm initializing my sum with 2 because when you start from 1, 2 is the first even number that you find, right? So the next thing I'm going to do here is I'm going to create a loop. Right, I'm going to create a loop. So I'm going to use while. In this case it's easier. You can use the for loop, it is still going to work, but now let's just let's just do something different. So here I'm going to say while next. We all know what the while loop does. In the while loop here we are going to set a condition that will keep the loop running. So what I'm saying here is while next is less than or equals to what? Limit. So we know that next is going to give us the Fibonacci of the next number. Right, so all I'm saying here is that as far as the next number we are getting is less than or equals to the limit, and this limit is where? Is what? Sorry, is 4 million. So as far as the next character is less than or equals to limit, so with this we will not exceed the limit, right? We are targeting only the values that are less than or equals to the limit. So we are not exceeding the limit. So while next is less than or equals to the limit, what should we do here? I need to what? Say next is equals to what? Term 1 plus term 2. This is not something new. We've already explained this. To get the next Fibonacci number, you need to sum term 1 and term 2. So if while next is less than or equals to limit, sum term 1 and term 2 to get the next value. Do you get it? That's where we get the next Fibonacci number. So the next thing we need to do here is we need to check right? We need to check if next, this same next here, this same number here, Fibonacci number, if it is divisible by 2. So I'll just say if next modulo 2, I want to check because here they say sum of even valued. So even number is a number that is divisible by 2 without remainder. That's why I'm doing setting this condition. So if next modulo 2 is equals to 0, it means what? That value of next is what? Is an even number, isn't it? So here I'll just say sum is equals to sum plus next. So with this, I have what? Don't forget I've initialized sum to 2 because 2 is the first even number, right? In natural numbers, 2 is the first even number. So I've already set sum to be equals to 2. So this is going to be 2 plus what? Next, isn't it? Because next is divisible by 2 without remainder. If next is not divisible by 2 without remainder, it is not going to sum it. So this part of the loop, of the if statement will not be executed. Okay, so the next thing we need to do is, after the if statement, what do we need to do? We need to update term 1 and term 2, right? So I will just say term 1 is equals to what? Term 1 is equals to term 2, just like the way we did in the previous example. Term 1 is equals to term 2 now. So what will term 2 be? So term 2 will now be equals to what? Next. So term 2 will now be equals to next. So this way I've updated the value of term 1 and term 2, right? So after each iteration, the values of term 1 and term 2 will be updated. I've already explained this in this previous example here, example 14. So if you don't understand what I'm doing here, refer to this task 14. I'm sure you will get it. Okay, so the next thing we need to do here is just print the answer. That's what the question says. It says we should what? Print the sum. So I'll just say printf and then what? Percentage %d, right, for the sum, and then on a new line /n, and then I will just say sum. So this is going to print the sum. Okay, this is going to print the sum here. All right, so let's check this. Before that, let's run Betty on the file 103. All right, so Betty is fine. So let's compile 103. Sorry. So let me just call it 3 here. All right, so run it. So as you can see, we got 461,732. 461,732. So this is the what? This is the summation of the even valid numbers. Okay, even valid numbers. This is the summation of the even valid numbers. 461,3732. Okay, so this is simply how to solve this problem here. Okay, so thank you very much. To meet in our next session. Don't forget to add, commit, and push to your GitHub repository. Bye bye.